Well, good afternoon. I'm Mr. Precella, and today this is a fun assignment. We'll be using the graphing tools that are embedded in MyLab for the first time. Or shall I say, it's embedded in Pearson MyLab, and they're very nice graphing tools, if I may say so myself. The thing about using these graphing tools is you have to know what you're trying to graph before you start using the tools. So here's a little brief review regarding graphing. Any flat surface can be referred to as a plane. So the plane I'm using is this piece of paper here. We can divide a plane using two number lines, a horizontal number line and a vertical number line. The horizontal number line is frequently referred to as the x-axis. The vertical number line is frequently referred to as the y-axis. Is this sounding familiar to y'all? Yes? The point of intersection corresponds to the number 0 on both of these number lines. So here's 0, that point of intersection point right there corresponds to 0. Move it just like with any horizontal number line. To the right is positive, and to the left is negative. And with the vertical number line, up is positive, and down is negative. Notice these two number lines divide the flat surface into 4 distinct regions. These regions are called quadrants. We start numbering the quadrants in the upper right hand corner. This corner right here is the first quadrant. I'll label it quadrant 1, and we use Roman numerals to number these things so as not to be confused with the numbers that are actually on the number line. And then we move in a counterclockwise direction. Quadrant 2, quadrant 3, I'll abbreviate quadrant with just quad, and quadrant 4. We can refer to any spot on this plane using something called an ordered pair. So this spot right here. You always start your movement here at the point of intersection of the two axes. As a result, that point of intersection is frequently called the origin, because that's where our movement originates from. You would have to move 2 units to the right to get positioned vertically underneath that red point there. So we'd say the x coordinate, or the first coordinate, is 2. Then we move up 1 to get to the actual point. So the x coordinate is 2, the y coordinate is 1. Realize it's called an ordered pair because the order in which you write those numbers is important. If you reverse those numbers to the point for the ordered pair 1, 2, you would go to the right 1 and up 2. Okay, someone give me the coordinates for this point here in the second quadrant. I agree. We'd go left 3 to get positioned right underneath that point. So the x coordinate is -3. We then go up 1 unit in the positive direction, so the y coordinate would be 1. I agree. What about this point down here in quadrant 3? Yes, -1, you go left 1 to position yourself vertically right above this red point, and then you go down 2. So the x-coordinate is -1, the y-coordinate is -2, and one more. How about this point right there? What would the coordinates be? Okay, we go 4 units to the right and then down 2, so 4, -2. In general, any point that's in the first quadrant, to get into the first quadrant, you'd have to go right and then up. So any point out here would have to have a positive x-coordinate and a positive y-coordinate. Well, for quadrant 2, we'd have to go left and then up. So the sign of the x-coordinate would have to be, you've got negative, the x-coordinate's negative, you're going left. The y-coordinate would have to be positive because you're going up. Following that same logic, what can we conclude about quadrant 3? The x-coordinate has what sign? And the y-coordinate? Negative as well. I agree. Left and down. Quadrant 4, okay, positive. You're going to the right and then negative. I want to look at some ordered pairs on the actual axes. Any spot can be represented using an ordered pair. So, I'm going to look at this one right here. Okay. Say I want to represent this point on the x-axis using an ordered pair. I always start at the origin. I'd have to move 4 units to the right to get to the same spot that that point's at. How many units up and down would I move? 0. What about this point right here on the x-axis? I'm trying to make a point here. We would go, okay, so we're moving to the left, so that's a -1, but the y-coordinate, since the point is still on the x-axis, how far up and or down are we going to move? 0. I agree. You should be able to convince yourself that if a point is on the x-axis, every y value has to be what? 0. On the x-axis, every y-coordinate has to be 0. What about points on the y-axis? Let's see here. Okay, let's express this point using an ordered pair. How many units left-right do we move? 0. So for that point, the x-coordinate is 0, but then we move up 4. So that spot there at 4 on the y-axis has an ordered pair representation of 0, 4. What about this one down here? Oh, I can't even see that little negative sign there. That's a negative there. There. How would we express this point using an ordered pair? Okay, we move left, right, 0. But the y-coordinate is -4. In order for a point to be on the y-axis, you can't move left, right. That means if a point's on the y-axis, every x value must be, for a y-axis point, the x value must equal what? 0. And that'll be significant later on. That'll be significant in a few minutes. Wow, that looks messy. Any questions? Okay. As I said, we're going to be graphing lines, quadratics, cubics, and absolute value expressions. So we're going to have 4 graphing tools. We're also going to graph square root expressions, but that'll be done using multiple choice. But there'll be 4 graphing tools that we'll be using in this section. And the first thing we're going to graph will be lines. if an equation represents a line, then you should be able to write it in the form ax plus by is equal to c. Where a, b, and c are numbers, the variables are x and y. Now, it's possible you won't have both an x or and a y. If a were 0, you'd only have a y. That's fine. If b were 0, you'd only have an x in the equation. But notice you don't have an x squared. You don't have a y squared. You don't have a variable, an exponent appearing on those letters. X and y are the variables. How many points do you need in order to draw a line? What's the minimum number? What's the fewest number of points you need to draw a line? 2, I agree. You need 2 points to draw a line. So, we'll look at number 1 from homework 9. Okay. Give ordered pairs that are solutions and graph the equation. They give us an equation, and notice they're giving us a table of values. We're going to be generating ordered pairs. We're going and eventually draw the graph. Let me write this problem down. Four y equals 5x minus 20. And they have a little table there for us. When I look at this equation, I notice I have x's, I have y's. I don't have any exponents on those x's or y's. I don't have them under square roots. So when I see this equation, I think to myself, this is a line. They have a table here, an XY table, and they have 0 sitting there in the X column. What they're trying to say there is to let X be 0 and find the value of Y. So they want us to let X equal 0. What does Y equal? So we come to the equation, we plug in 0 for X. That says 4Y is equal to, now 5 times 0, I like plugging in 0 because whatever you, when you plug in that 0, what's this term going to become? 5 times 0 is just 0 minus 20. And we know 0 minus 20 is negative 20. Then divide both sides by 4. We're solving for y. And what are we about to get? Negative 20 divided by 4, I agree, is negative 5. So, we switch over. Here, I put in a negative 5 for y. Now, we said that we needed how many points to draw a line? 2. Okay. We're not through with the table. Look at this. They have a new row on this table. What is this new row saying to do? Okay. The 0 is there for y, so they're saying let y be 0. What does x equal? So we come back over here. Oh, wait. Oh, and by the way, since my brother isn't here, when I do something like that, call it out immediately, okay? I don't want to work through the whole problem and discover that y'all haven't seen what I was writing. So we this says let y equals 0, solve for x. 4 times 0 is 0 equals, we have a 5x minus 20. Well, we got to solve for x. I think I'd move this 20 over. Adding 20 to both sides, we'd have what here? 20 equals 5x. And then to solve for x, we divide by 5, I agree, to give us x equals 4. So we have a second ordered pair. Realize we've generated ordered pairs. That's what this equation does. You give me a number to plug in, and I can generate the respective ordered pair. But we have two ordered pairs, 0, negative 5, and 4, 0. So we come over here. Oh, what goes in this box? 4, I agree. And what I prefer to do, I didn't used to. I used to prefer just to use the graph that was right here. But over the years, I've decided I prefer just to enlarge the graph. I'm going to use this little pop-out. Do you see where I'm clicking, click to enlarge graph? Okay. Choose a tool in the palette and follow the instructions to create your graph. Here are the tools. Okay, we're drawing a line, so we have to find a thing that's the line tool. This thing right there is just, you're not ever using that, and that's just the pointer. But if you move right next door to it, and you hover right there, what does that say? If you look very closely, there are two little blue dots on that line there. That's what we have. We have two ordered pairs, and we're drawing a line. It says line tool. So we're drawing a line. That's why I said you have to know what you're trying to draw before you can use these tools. So you click there, and as soon as you click the line tool, notice it says click the graph to plot the first point on your line. As you move around here, y'all see up here in this yellow box? You see that yellow box there? It's showing you where your pointer is, okay? And for some of these, the increments are going to be very tight. It'll be hard to count those units. So just look up there as you move your mouse around to make sure you have your point at the spot you want. So the first point, 0, negative 5. Is that the one I wanted? Yes, looking up there in the right-hand side of that yellow box, it says 0, negative 5, so I click it. Now it says click the second point. And notice, as I move my mouse around, it's showing every point that could possibly, every graph, line that you could have passing through that point 0, negative 5. But the second point, what was that second point? We just plotted 0, negative 5, so now we're ready for 4, 0. So we come over back here, 4, 0. Is that 4, 0? Yes, you see where it says 4, 0 in that yellow box. I click that. Then I have to transfer this graph back to the original grid. So you click Save, and hold on. Then say Check Answer. Any questions there? Okay, let's do another one. When I look at this equation in number 2, what sort of graph do I expect to get? Another line. Notice we have x and y, no x squared, no x cubed, no square roots. This graph is going to be a line. So number 2, let me write it down. (4x plus 3y) is equal to 12. Hey, they're not giving us tables of values here. In this case, it looks like they're giving us ordered pairs. So they have this ordered pair. What is that saying to do? They have this ordered pair right there. And we need to fill in. Need to fill in that ordered pair. So what is this thing saying to do? Okay, the first number is x. So you plug in 0 for x. Let x equal 0. What does y equal? 4 times 0 is just 0. Plus 3y, 0 plus anything is just anything. So really all we have is 3y equals 12. That's why I think plugging in 0 is so nice. That variable term just disappears and we know what to do to solve for y. One step. What is it? Divide by 3. To give us y equals 4. So we go back over here, and in that blue box there, we complete the ordered pair by typing in a 4. But we need 2 points to draw a line. I bet you they're going to have another ordered pair for us. Oh, look at that. Here's another ordered pair they have for us. In this case, the box is in the first spot. So what is this second ordered pair telling us to do? Plug in 0 for y. That second number is the y value. Solve for x. So we're plugging in 0 for y. What does x equal? So we have 4x. 3 times 0 is 0. So 4x plus 0 is just 4x equals 12. So we divide by 4 to get us our x value of 3. Any questions there? Okay, so we come here and we type in a 3. And it's time to draw a graph. Now listen, if you're one of the view and example people, I should warn you, they're not going to really show you how to, if you view an example, continue, they tell you what to do to solve, to get the ordered pairs. Wow, that's a lot of work just to complete those ordered pairs. And now it's time to draw the graph. So, they're plotting and plotting, and there's the line. But you'll notice they're not telling you, showing you how to do it with the...
but the way you teach is in the way that... Oh my God.
This is not a good... The view an example here in this section is not good because it doesn't show you how to use those graphing tools. Okay, that's what I'm trying to show today. How we use these graphing tools. Well, we've already done... you tell me what to do first. Click the line, this thing here. Okay, there. And now we want the first point. Now realize the points themselves, there's no special way that you have to enter them in. Here are the two ordered pairs, 0, 4, and 3, 0. You could put in you could plot 3, 0 first and then 0, 4. The order in which you plot the ordered pairs doesn't matter. So just for illustration's sake, I think I'm going to plot 3, 0 first, just to show you you'll still get the same line. So now we're going to click there, 3, 0. Is that it? Yes. And then what was the other one? 0, 4. Is that it? Y'all see there in that yellow box where it says 0, 4. Click. Save. Check answers. These points where the graph intersects the x and y axes are called intercepts. The point where the graph passes through the x-axis is called the x. Let me switch over. The x-intercept. The x-intercept is the point where the graph passes through the x-axis. Point, I'll say intersects, where graph intersects the x-axis. And the y-intercept, that's the point where the graph intersects the y-axis. And so the x-intercept, that's where the graph passes through the x-axis. The y-intercept, that's where the graph passes through the y-axis. And remember something we said earlier. If a point is on the x-axis, then the y value has to be 0. That's how we found those x-intercepts in problem 1 and 2. For the x-intercept, the y value was 0. And for the y-intercept, the points on the y-axis, we said they all have the same x value of 0. So for the y-intercept, we set x equal to 0. Any questions there? Okay. The second thing we're going to be graphing is quadratics. A quadratic equation, well, you tell me, a quadratic equation, what exponent has to appear in the equation to be quadratic? Square. So for quadratics, you've got to have, your equation contains x squares. Not an x cube or an x to the fifth. It has to have an x square. That's how you can spot a quadratic. The graph of a quadratic is a smooth U-shaped figure called a parabola. P-A-R-A-B-O-L-A. We're going to do a lot with quadratics later on, okay? Here we're just going to be plotting points. It's nothing real sophisticated. We're just going to plot points to draw the graph. The U-shaped figure will either be opening upward or it could be opening downward. And as I said, in a couple of assignments, in a couple of weeks, we'll be looking at quadratics in more detail. But for right now, we're just going to be plotting points to get the graph drawn. And to illustrate, let's look at number 3. For the equation y equals x squared minus 4, create a table with at least 3 ordered pairs that are solutions, and then graph the equation. Well, it's going to be exactly 3. When you're graphing a quadratic using this tool, you'll need 3 ordered pairs. It's a 3-point quadratic tool that we'll be using. And notice they've made us a little table of values. So let me write this problem down. The equation we're trying to graph is y equals x squared minus 4. that doesn't sound very confident. This equation we're trying to graph, the equation we're going to graph, okay, is y equals x squared minus 4. Yes. No, let me write the problem down completely first. I'm still copying down the problem. -2, 0, and +2. And let me make sure I didn't miscopy. Y equals x squared minus 4. We're plugging in. Hey, looking at this table, are we going to be plugging in anything for y? No. The only numbers we're plugging in are x values. That's nice. And we're plugging in -2, 0, +2. So, we'll start with that first line. That's saying let x be -2. X is -2. So y is equal to -2 squared minus 4. What's -2 times -2? That's a +4. Negative times negative is positive. So we have a 4 minus 4. What am I getting for my y value? 0. I agree. So we just generated the ordered pair -2, 0. This second row of the table is saying let x be 0 and solve for y. So we have y equals, oh, this is painless, 0 squared is what? 0 to any power is 0. 0 minus 4 gives me a y value of okay, 0 minus 4, -4. There's my second order pair. The last row of the table, we're letting x equal +2. X equals +2. So y is equal to 2 squared minus 4. 2 squared is 4. Minus 4 gives me a y value of 0 again. Okay. So we have 3 ordered pairs. We have the ordered pair -2, 0, the ordered pair 0, -4, and the ordered pair 2, 0. So we're going to have to go to MyLab and we'll have to type in these y coordinates. 0, -4, 0. 0, -4, 0. Check answer. And click to enlarge the graph. And once again, I said you have to know what you're going to be graphing in order to use these tools. Because of that square, the square that we saw there in the problem, this square, that's what said it's a quadratic. So we got to find the quadratic tool. Which one of these tools, if we hover, we know that's a line. If we hover over this V shape, you see, to me a V has a sharp point. A U is smooth down at the bottom, but a V has a sharp point. That's the absolute value tool. We'll see that. That's the most involved tool that we'll be using, the absolute value tool. We'll see that later in class. If I move down here, 3-point quadratic tool. Isn't that what we want? We said it's quadratic. And how many ordered pairs did we create? 3. So we want 3. And now, if the parabola opens downward, you still, remember I said that a parabola will either open up or down. Even if it opens down, you still click that little U that looks like it's opening upward, okay? So, let's come over here. I'm going to click the quadratic tool. And it says, click the first point. It doesn't matter which point you use. It doesn't matter which one. I could use 2, 0 instead of negative 2, 0. The line, quadratic, and cubic tools, you can click those points any way you want to. The absolute value tool that we'll be seeing in about 20 minutes, the order does matter, okay? But for this thing here, it doesn't matter. Just click a point. So I'll say negative 2, 0. There's the first one. What's the next point we want? 0, negative 4. Is that 0, negative 4? Do y'all see the coordinates there in that yellow box? Yes. And now it says plot the last point. What was the last point? But notice as I move my mouse around, this thing it'll draw in every possible parabola containing those 2 points. Okay, but what was the third one? 2, 0. Is that it? Click it. Then you've got to transfer it back to the original grid. So you say save, check answer. Any questions there? Yes. Well, when we look at these things in more detail, we're going to discover that the coefficient of x squared, the number in front of x, will decide whether it opens up or down. I don't see a number there in front of x squared, so what do we assume that coefficient is? What do we assume that number? If you don't see a coefficient, what do you assume it is? If you have a letter without a number in front, 1. It's positive. If the leading coefficient is positive, the parabola will always open upward. Now, if the leading coefficient is negative, it's going to open downward. And that was really a good question because look at number 7. Okay, let me write it down. Hey, this is interesting. It doesn't give us any points. It just says to graph y equals negative 2x squared. This is number 7. Let me write the problem down. And you'll notice it's not giving us a table of values. It's not telling us what numbers to plug in. We're going to have to choose our own numbers. But realize, look at this grid that we have. Any point we generate has to fit on this little grid here. So you can't decide, oh, I'm going to plug in 10. I was asking the Tuesday-Thursday class, and I think someone said, oh, they wanted to plug in 5. Well, 5 squared is 25 times negative 2 is negative 50. Can we label a y coordinate of negative 50 on this grid? So my advice to you, choose numbers real close to 0 so that you don't wind up with points that are going off the grid. Okay? And let's see, I think I'll just, how about some numbers that are real easy to plug in, nothing too big, but we need 3 of them. How about negative 1, 0, and positive 1? You could decide to use 10 for x. Well, you'll get negative 200 for y. You're not going to be able to plot it. So you have to look there and recognize the limitation. This graphing tool is nice, but you got to be able to plot whatever points you generate on that. So you have to choose x values that are going to give you small y values. Oh, starting off with x equals negative 1. We get y equals negative 2 times negative 1 squared. Remember your order of operations. You perform exponentiation before you multiply. So what's negative 1 squared? What's negative 1 times negative 1? 1 times negative 2 gives me a y value of negative 2. Oh, what happened? Uh-oh. Oh, it's frozen up. So what do y'all think happened here? Why did it freeze on my hand? I mean, my hands are right here. They're not there at the pen, right? This happened last week, and the only solution was for us to